My name is Joe Goldberg. I'm with BMC Software, and I'm going to be talking during this session about a topic that's very near and dear to my heart, but it's actually been very interesting to see just how many people are struggling with the topic and the general area of managing batch. I came in just a few minutes towards the end of the previous session, which was about building out a self-service data analytics platform. And the last 5 or 10 minutes that I caught of the session, it was all about choices about how to manage batch. So that's what this session is about. I'm curious, by a show of hands, how many of you are familiar with Oozie? Of those of you that are familiar with Oozie, how many of you are happy with Oozie or like it or would describe it in some positive way? Okay. Okay, so I've had a lot of very interesting conversations, including with some Oozie committers just about this very topic, and it's been very interesting. So obviously, as you can see from the title, you probably can guess what our opinion is, but what I'm going to talk about today is this whole area of managing batch from a Hadoop perspective, but you know, very quickly the conversation becomes much broader than just Hadoop. Okay. When it comes to Hadoop in general, certainly the perception I have, and that I think you see from many conversations, from attendees at sessions like this, reading trade publications and listening to analysts, everybody is massively interested in Hadoop and big data. There's a tremendous amount of interest. It's top of mind. It's exciting technology. But when you ask about how many people are actually running something that is in production, meaning that there is some business function or business process that if it were to stop or break, that somebody would care about it, then it is a relatively low percentage of people relative to the level of interest. And you know, there's lots of surveys and there's lots of discussion about why that is. Certainly learning new technology, finding the people with the right skills, those are some of the significant challenges, but there's also, I'm not sure where I'm supposed to point this to get this to, okay. But one of the items that always comes up on a list of the top, you know, 3, 5, whatever, challenges of implementing Hadoop and delivering big data applications are the challenges of integrating that technology with the rest of what you already have. And specifically from a Hortonworks perspective, so as you know, Hortonworks, of course, provides their HDP platform. It's free of charge. It's open source. Hortonworks makes its money on helping people solve problems on subscription services. And they recently sent out an email, which perhaps some of you or many of you received, showing their breakdown of the top problems that customers are encountering actually operationalizing or gaining value or going into production with Hadoop. And as you can see on that list, number 1 is building configuration, as you might expect, but number 2 is executing jobs. And that may be a bit of a surprise, considering that we have very quickly pivoted from perhaps a year ago, before Hadoop 2 came into the market. Hadoop 1 was pretty much 100% batch. With Hadoop 2 and Yarn and various alternatives for how you can run workload in that environment, I think we as practitioners have started looking at or focusing on what seems like the more interesting, more enticing side of Hadoop and big data, which is real-time streaming. But the reality is that still, if not 100%, now it's 70, 80%, a significant portion of what happens in a Hadoop environment, in a big data environment, is still being done in batch. And even we've had lots of conversations with data scientists and people who work with data that they may do their work interactively, let's say exploring and designing algorithms, but eventually when they complete that phase and they want to turn it over and make it sort of operational on a regular basis, batch becomes either the primary vehicle for delivering those kinds of capabilities, or at least an important factor. And so, you know, if you look at what is a typical Hadoop project, it doesn't really matter if you're starting an initial sort of research phase or a POC, and eventually if you're even running in production, it looks a lot like pretty much any other kind of project, right? There's a lot of data sources where those data sources frequently, at least some, and perhaps even most, are outside of Hadoop. So you have conventional, let's say, relational databases. We've even talked to customers that, God forbid, they have mainframes and DB2 data. There's external data that is coming into the organization, perhaps from social media, other kinds of feeds, machine data, web logs, things of that sort. And there's also a lot of data that the organization already has that maybe is archived, or let's say it's dark data that they want to revitalize, but there's a whole bunch of data. And the first part of being able to start up and kind of work with that is having to get that data, either move it, there's constant feeds, and so, you know, there's this constant need to sort of orchestrate data flow, pipelining the data, and managing the flow of the data into, let's say, a Hadoop or a big data environment. I keep saying Hadoop, but you know, especially nowadays with the discussion of how you're going to, let's say, what are the choices, and whether it's, you know, you're running Mesos as opposed to Yarn, or whether you're running Spark on Hadoop, without Hadoop, it doesn't really matter. So, you know, very generically, Hadoop and big data I'm using sort of synonymously. So you have to manage the data flows, the feeds, the things that happen with this data coming in. There's the processing within that environment, and then there are results. And typically, the results of that processing also come in two categories. They're either for human consumption, you know, updating dashboards, producing information that someone looks at interactively, or sort of perpetuating this cycle of pushing that data back out to other applications, whether those other applications are back in sort of the traditional IT space, or perhaps they are new applications that will be built in the Hadoop space, doesn't really matter. So there is this constant sort of flow of data and processing that occurs, and the choice for doing that is some kind of a method for managing the batch processing that accomplishes or supports much of this. So if we were to take a look at, let's say, a typical kind of a big data project, somebody starts off, let's say they have a traditional sort of relational database, some kind of a SQL data source. So let's say they're using, I don't know, SQL Server or Oracle or Postgres. It doesn't matter what the choice is. The process is that you got to write some of that code, you develop some queries, you do that stuff, and then you want to run it. You need to run it to verify that it's running successfully, to test that it's giving you the data that you want it to have. And not surprisingly, every single tool you're going to use has some kind of a batch scheduler. They have batch schedulers because batch is so important. But they all have sort of the same repeating limitation. So let's say this is actually a screenshot of SQL Server. So you run some SQL agent jobs. Maybe you have some ETL processing. Let's say Informatica, for example. But you know, replace that with whatever your favorite or popular, and whether it's ETL or you want to describe it as ELT, you know, that's not really that important. But you go through the same kind of process. You develop something in that technology. You have to go through the process of creating that, of course, and then you need to run it. And you're going to run it initially to test it, to make sure that it works, and then as part of the ongoing process to prepare or be part of the overall flow of how you're going to run and manage the thing that you're going to be delivering. And you can repeat. And I've only chosen a few. Let's say with data movement, you may have some kind of a file transfer facility. And this too is going to have some kind of a user interface and a component and something that you have to learn. And then you get to Hadoop. And of course, there are other options, but I'm going to pick on Oozie because it is the most common. And it's the same thing. Not only do you have to write your, whether it's Java code or Python or whatever it is that you're writing, you just develop some code, and then you're going to have to run it. Now, when you have to run it, you're going to start using Oozie, most likely. And whether it's pure Oozie, whether you're going to run it by hand and, use either an Oozie CLI, whether you're going to use the user interface, use Hue on top of that, whatever manifestations, it is going to be still specific to this environment. And so you have a situation where in order to just basic operation, you need somebody who can do this kind of thing. You've got to drive like 42 different technologies just to be able to do the fundamental basic operations of running this stuff and perhaps doing the initial testing to get it done. Okay? And so nobody has too many people like this, and if you have a person who is capable of this kind of thing, they don't want to do this either. It takes a lot of their time. And so we have seen and talked to a lot of customers and read a lot of sort of blogs and presentations about what it is that developers look for when they want to find a batch or workflow management platform or engine. And there's a whole list of things that you would expect. And it's really not much different than any other technology that you would select. But the thing is that this is going on in almost every organization that I have talked to, all the people that have stopped by our booth that we have the opportunity to talk to. And so this is constantly going on. And of course, needless to say, if you look at what, if you sort of compare these list of high-level capabilities that people look for against what Oozie can deliver, there are a number of shortcomings. But even if that were not the case, the context is that you're using and driving or having to familiarize yourself and do the work of sort of integrating or accommodating all of these different tools and technologies. And so what typically winds up happening is programmers who are doing this work say, well, we have a better way. We know how to do it better. What they're going to do is they're going to start writing a lot of scripts. And each one of these scripts, no matter how fast or how good they are, you have to write them. You have to debug them. And in each one of them, there's going to be a lot of complexity. You have to learn that technology, right? You have to learn how to connect to the application. You have to make sure you handle credentials. You have to capture the output. So there are these kind of repetitive things, and this is kind of what we see happening over and over again. Now, typically what might happen is that you get these little scriptlets, perhaps, that get written for each particular technology, and then eventually to run the thing, you kind of put it all together. We've had some of our customers talk to us about what they call mega scripts, right? That all of that becomes one single script. And within that, you're doing all of the work of initializing environment A, connecting to the application, running the application, collecting the output, managing the logs, collecting and checking status and return codes. And then you do it for technology B and C and so forth. And this thing becomes rather large and unwieldy. And at the end of all that, that's what you're going to run perhaps with Oozie. So the problem is that even though you have spent all of that time, even if you may argue, well, we did that for our first project, and then for the next 20, we just kind of replicated that same thing with only just some minor changes here and there, which make each one of them unique and therefore problematic. When this stuff runs, and it doesn't matter who is running it, as there's a lot of discussion about moving Hadoop and big data projects and applications into the enterprise, people consider, well, maybe it's going to be IT that's going to run it. Frequently, that doesn't happen, that in order to operationalize this much, much more quickly, the same teams that develop it are kind of either charged with, asked, or they themselves, in order to meet their target deadlines, are going to run them. And so regardless of what happens or who is going to be running it, you have the problems of managing these monolithic collections of code that become very problematic. It's very difficult to understand as your applications get more complex and there's more of this kind of interaction of data flows and applications and components. What is the relationship? What's more important? If something failed, what's going to be the downstream implications? What are the flow lineages associated with this? So it becomes difficult. Timing becomes important. In a business context, you need to do something either by a particular time or within a particular time frame. and things like whether you want to call them formal service levels or just informal needing to know when things are going to run, when things are going to be available, it's very difficult. Because if a script has 10 things in it, and it runs for an hour or 10 hours or 3 seconds, you really don't know after it's run 20% of the time it's run, are you on the first step, the second step? Are you almost done? It spent 20% of the time it ran yesterday, but does that mean that's 20% done? You really have no way to know. Or I should say, it's very difficult to know. In most cases, you really have no way to know. And the larger these things become, the more cumbersome they become, the more problematic that problem. And if something fails, then your problems really start. You know, like, who wrote this code? Who understands it? What language is it in? Do we have somebody available and on call that can actually look at it and debug it? Where are the logs? We figured out the problem. Can we restart? Where do we restart? How do we restart? This thing ran for 4 hours. Do we have to just start all over again and lose those 4 hours, or can we restart somewhere in the middle? If you get more formal as you're moving closer to the enterprise, how do you do problem management? How do you inform people that there was a problem, that things are delayed? Is there some kind of a tracking mechanism? If something failed today, how did it run last time? So there's this myriad questions that begin to arise in an operational environment, all of which are very difficult to answer. So, of course, those are all the problems. And there are many, many, many more. The more mature you get, the more downstream you get towards actual production, you have to deal with business users, people who are less technical. They have an interest. They may need to be able to run some of the stuff themselves. How do they do that when you're using tools or technology that is relatively complex? You know? Of course, there's things like governance and being able to forecast and do impact analysis of changes to the environment and a million other things that nobody, or I should say very few people when they're starting Hadoop projects are thinking about. But you know, I've been sort of watching this industry now with this market for a couple of years, and it has moved from sort of science project research just like a year and a half or two ago to becoming almost entirely focused on moving towards the enterprise business value. And so these kinds of questions are going to continue to become more and more important. And especially among customers that are, you know, some of like our typical customers, which are sort of in the global 2000, and companies that have regulatory requirements and all kinds of audit, and they deal with personal information. These kinds of problems, there's some leeway initially, but eventually they become very, very, you know, critical to be able to address. And so for all of those, that's really kind of the rest of what I want to talk about, and that is a tool called Control-M. So BMC as a company, I didn't really spend any time talking about it, so I'll be very, very brief. BMC as a company has been around for about 30 years. We focus on IT management solutions, you know, automation tools, and one of them is a job scheduler, batch, job scheduler, workflow engine, whatever you want to call it. It is a commercial tool. But it has been in the market, and it is the leader in its market in the commercial space. It's been available for a little bit over 30 years. We started on the mainframe, and today we support every commercial platform and application that you can think of. Not only the platforms such as mainframe, Windows, Unix, Linux, AS400s, OpenVMS, Tandem, you know, stuff that you probably don't really care about if you're doing Hadoop, but also ETLs, ERPs, relational databases, file transfer and data movement products. You know, we have generic web services, messaging capabilities, and we even have an open platform that allows you to build or to define on-the-fly integration with any application that has an automation set of automation APIs. And so that's what we offer. And we think that there is very significant value to kind of look at this because it addresses a need that has been huge in this place, in this market. And so I want to talk about this a little bit more. What you see here is the user interface from our solution. There are different components here that let you, what we call domains, where you either define and manipulate workflows, others where you run and monitor them. And what we have done is we have added native support for Hadoop to this application. And so whether you are running, MapReduce, Pig, Hive, Scoop, if you're going to be expanding and looking at, Spark or Flume or commercial tools like Splunk, visualization and analytics tools like Talend or Datameter or whatever it is that you can think of, all of those tools today have some kind of a batch component. They all have their own scheduler because, as I mentioned earlier, batch is such a critical component that everybody has to provide some kind of a support for it. But rather than having to think about how are you going to run and manage jobs every time you add a new Apache project or a new commercial tool, what we have done is really abstracted the entire notion of managing jobs and given you a single consistent a way to approach managing jobs across the environment, no matter what your complexity is. So if you are doing only Hadoop, then all of the sort of challenges that I described with managing just an intra-Hadoop project, we think we make it much, much easier to manage with an easier to use UI. We make it easier to build workflows. So we obviate the need for building all of that integration and committing it to code and having to develop it and to test it and then have all of the associated issues that I described with running it. Instead, you have a drag and drop interface. We have built-in integration with all of these applications. So when you pull together a workflow, a job is a single, simple object that already has built into it all the capabilities of defining how you connect to that application. That Control-M knows how to do that. I'll show you that momentarily in something we call a connection profile. We already automatically will verify success or failure. And if it's successful by default, then successors can run. If a particular job fails by default, its successors do not run. You can actually define or redefine what is success as well as what are the actions downstream. So if you want to be able to say, this failed, but that's okay, I still want to run successors, you can do that. If the typical success is an exit code of 0 out of whatever process you're running, but in your case you want to look at the output and make sure that there aren't any nasty messages that perhaps indicate some other failure, you can do that too. And what you get is a single end-to-end view of your entire process in a single solution, so that as you have the relationships and the flows of the complex components in a typical process that makes up a big data and pretty much any kind of application today, you have the ability to see that progression. You get color-coded indication and status. We do notification if anything fails and a bunch of other things, as we'll talk momentarily. So this is what a Control-M Hadoop job looks like. All of our jobs have sort of a graphical form where you define what you want to run. Notice that, I guess I have to say it, even though we're here at a Hadoop summit, we are partners with not only Hortonworks but also Cloudera and MapR, and we support all Hadoop distributions. Our UI and our, the API mechanisms use standard facilities that are part of whether it's Apache Hadoop or anybody else's Hadoop distribution. We support them all. The way you define a job is with a graphical form, and there are probably somewhere in the order of up to 100 different parameters that you can specify and different attributes that you can specify for a job, but the vast majority of those are exactly the same regardless of the job type. So it really doesn't matter whether you are defining an ETL workflow in Informatica or a MapReduce that you're going to be running. The way you define general attributes that define a name, calendaring or scheduling information as to which days you want to run this or which times, or whether you want to run it multiple times every minute or every 10 minutes or 3 times a day. The relationships, the post-processing actions, what happens when a job fails, or if it's successful, who do you notify? Do you want to open incidents if there's a failure? Do you want to invoke other jobs? Do you want to take corrective actions by adding additional jobs onto your environment? All of those things are exactly the same, regardless of whether you are running a pig script or whether you're running any other kind of a job. There is a small section which is application specific, which is what you have in front of you, sort of the middle of the screenshot, where you tell Control-M, I am running a pig or a hive or a MapReduce or a streaming job or Tajo or HDFS commands. And then that section is specific to the application that you have selected. And there are parameters you can specify or capabilities that are unique to that application. So what you have here in the screenshot, that if you think about how you script some of your invocations, it's very common that when you are going to run something, you might do some file cleanup before or create directories. And so we have what we call pre and post HDFS commands that you can specify before you invoke and run, let's say, a MapReduce job. You can even specify whether the failure or success of those HDFS operations should be a determining factor in whether the job runs or not. So if I am just deleting a file in case it is there, and if the delete fails because the file doesn't exist, that's fine because what I'm really doing is creating the file. Then you can say I'm going to do an HDFS remove of a file, but if that fails, that's fine, continue anyway. Or maybe you have to create a directory and your code expects that directory structure to be in place, otherwise you're going to get undesirable results, let's say. Then you can say I'm going to create a directory, but if that fails, fail the job, don't run the code because it's dependent on it. So it makes the process very straightforward, and what makes this really great is that if you have even a small subset of these kind of technology collections that I spoke about, and you have relational databases that you want to issue some queries against or run store procedures, and then you want to do some file transfer, and then you want to run your MapReduce, and that's kind of your typical flow. Once you learn how to define any job in Control-M, learning how to define any other kind of a job is a matter of minutes, because the vast majority of the rest of the process, how you build jobs, how you run them and monitor and do everything else, is exactly the same, completely consistent. So that's how you define a job. Okay. And then when you have to build a process, this is kind of how you build it. This is PowerPoint animation, so it's a little bit spotty, but this is exactly how it works. What you see in the upper left-hand corner is the job palette. It has all of the different job types that you have in your environment that you've defined, and you just simply click and drag it onto the palette and then connect them. And you can connect that flow, as you can see, a whole bunch of things in this particular example, where we've had this kind of composite collection of technology, and we were able to create this flow. Okay. If we then move on and look at, okay, what else may I want to do? What else is important to me? So there's the concept of managing, whether you call them formally service levels or when things need to complete, whether you're doing this on behalf of some business user and you provide a service or you want to allow them to do it themselves. There is this notion that people kind of need to have some idea of how things run. And so in our environment, you can define SLAs. You actually define them and you codify it for the stream. So you don't do it on a job-by-job basis, and all you have to do is kind of point at where is your milestone or completion point, define your criteria, and then the solution does all the other work. It discovers the entire collection of predecessors and successors and collects that entire set of jobs into what we call a service path. And then it uses statistical information to watch the entire thing execute and gives you the earliest possible notification if there are any delays. It also, even if everything is running fine, if that entire flow, whether it runs a few minutes or whether it runs hours or even days, at any point in time, you know exactly where you are up to without having to look at the details. There's a service view that lets you see the entire collection of work you have in your environment that is based on services, where services are whatever you call them. And it'll tell you that there are 395 jobs in the service, 42 have completed. That means that we're, whatever, 10% done. The projected completion time based on statistics is whatever it is, and right now everything's running okay. Or if there's a problem, you get that notification too. So you get this information, and then you have the ability to also take action. Not only can you take action, but you can also do real-time analysis on the collection. You can set what we call what-if scenarios and say what would happen if I skipped some jobs, or maybe if I provisioned some additional resources, would that allow me to finish on time? We also provide a very rich set of capabilities to manage change. Okay? Nobody is thinking of change, or few people are thinking of change when they're developing their initial projects. But as soon as you finish developing, you've got to think about revs and how that gets managed. You got to think about audit trails, or being able to track back if there's a problem as to who changed what. And we have a full range of those capabilities. Not only can you track all that information, but there's also a graphical forecasting ability that also has these what-if scenario capabilities. So if you're familiar with things like, in Excel, there's like a goal-seeking mode where you can say, this is where I want to get to, and work your way back and tell me how I can get there. You have the same kind of capability with jobs, where you can open up a collection or a workflow and say, I have this requirement, or I'm changing something, and I'm changing my requirement. How can I get there? When do things need to start? How long do they run? And ability to track that. As well as you change any of your workflows, there's a complete version history that is maintained. You can look at what was the previous version, who changed what. If you want to revert back to an older version, you can do that. All of those capabilities are there. I had mentioned also this notion of what we call a connection profile, which actually has some very interesting characteristics. So again, one of the things we've seen in almost every script that is used to connect to an application. And this is true for Hadoop as well as ETLs and any other application. You've got to have some information about where that application instance lives. What server is it on? What port is it listening on? What are the credentials that I use to connect? What libraries am I using when I run whatever it is that I run? We take all that information and we put it into an object we call a connection profile. And then when you define jobs, you just simply point to or select a connection profile. This has given us the interesting capability of being able to support, multiple Hadoop clusters, for example, all as a single solution. Different vendors. It's particularly interesting to have heard from a number of people that are doing POCs and doing vendor selection, and they're standing up a cluster from the major distributions, and they don't want to have to sort of recreate their test cases. You have now the ability to run them all simultaneously from a single solution. You also certainly can support, a test and a prod and all of those kinds of things. And if you change your environment, you change this connection profile, you don't have to change any of the jobs that refer to this connection profile. So it has some really important characteristics that way. When jobs eventually do get into, you've built jobs, you've built flows, and you get into execution, this is part of our Hadoop specific support, where for all applications that we run, we collect, automatically capture the output of the job, standard out that's available. You can click on any job object and say, let me look at the output. We archive that automatically. You can specify retention, so you can keep it for a day or a year or however long you need to. But we also, in the case of, this is an example where I think we were running a scoop job which translated into only a single MapReduce, but you can see the link there, and you can actually get tracker logs. So whether you're running, I don't think anybody's running Hadoop 1 anymore, but whether it's job tracker, yarn, it doesn't matter. We pull back that information and bring it also to a single user interface, so that if you are doing an analysis and you have a complex composite job or workflow consisting of all the things I mentioned, you get all the output in one place in one tool. And you can access it through a variety of ways, including not only, we have sort of simplified interfaces for what we call self-service for business users, or let's say less technical users, and you even have that information available from mobile devices, any iOS or Android device, which is what you see on the right-hand side. Sort of the last piece from a technical perspective that I want to touch on, obviously, lots of people are not familiar with our solution. However, when they learn about our solution, they frequently get very excited. And they say, hey, this is great, but I already have a whole ton of Oozie jobs. And so we have a conversion utility. And it converts a whole bunch of stuff, including all kinds of competitive tools of ours in other environments. But we have added support to Oozie. And basically, you can either just extract, or if you already have it extracted in advance, the XML for your workflows, you can just simply input into this conversion tool, and it will then generate the control M equivalents for those workflows. So, kind of in summary from our perspective, we see that there are sort of three major areas of value that we think are valuable with our solution for anybody who is doing Hadoop or big data. Based on a lot of conversations we've had, customers can save, and developers can save 10, 20, 30% of the time that it takes to develop applications. And nowadays, especially in this market, people who are able to actually build these kinds of applications are very difficult to find, and they're very expensive. And the last thing that you would want to do is kind of have them constantly reinventing the wheel, building code that is not even necessary. And I would argue that since we've been doing this for about 30 years, that we're better at managing batch than they ever will be with the scripts that they write. So let them save their time and get a better product, and we think that that would make a significant difference in terms of how quickly you can deliver new applications. Once you've built them this way, you're going to be able to run them much more effectively. All of the problems I talked about, obviously, those are problems that we solve. You get far greater visibility. It's much more granular. Each process is an individual object that you can not only see and visualize, but act on. You can see the entire flow. You get better timing. You get better operational capabilities. You get all of those benefits in terms of operational runtime benefits. And even if it is the Hadoop developers or the big data developers that are running your initial projects, they'll be able to sleep better or longer, and if there is a problem, they'll be able to find it and solve it more quickly. And so that's a huge benefit as well, not only to developers as you're kind of getting up, ramping up with big data applications, but certainly down the road when you operationalize them. And then finally, this technology is only going to become more prevalent. This process that we are seeing is only going to continue to occur and over and over and over again. And so we think that this approach of abstracting the whole concept of how you manage jobs and being able to do it consistently is something that will give lasting value and tremendous flexibility to the business going forward. Because, you can throw out names. This is just going on and on and on, whether it's commercial applications and or open source. Each one of them brings new or slightly modified challenges for managing batch, and we have a platform that really lets you manage all of them. As far as BMC software, so we've entered into this market about 2 years ago, but as a company, we've been around for quite a long time. We are the market leader in our market segment in the traditional space, and really our goal is to become the market leader and the provider of choice for managing batch in every environment. As far as Hadoop Summits are concerned here, we've been at several here. We are a platinum sponsor. Unfortunately, the exhibit floor is now closed. I can't tell you to come to our booth, but if you're in San Jose in June, come visit us then. We're also going to be in Strata, and so we have made a major investment into this market, and we have definite plans to be a permanent fixture in this space. And finally, if you do want any more information, obviously speak to me. I have a couple of other colleagues, anybody from BMC that you may be aware of, or go to bmc.com. There's a lot more information that you can get about our solutions and what we have to offer. And with that, and 39 seconds left, I will open this up and see if there are any questions about anything I talked about. Yes?
What is the control flow capabilities your tool has?
Yes, absolutely. So that's one of the things that also, it's interesting that there's this focus. Oh, the question was whether we can do loops and conditional branching, and the answer is yes. So we are not a DAG. We don't believe that scheduling should be a DAG, because you definitely do need to kind of loop back and sometimes, but we have full flexibility. You can recycle, or you can define objects that are cyclic, as we call them, which means that they will run every n minutes, or however frequently. The entire flow can then cycle that way. You can have trees that define, this is the path if something fails, this is the path if it succeeds, and so forth. Yeah.
If I want to integrate, use your system and integrate something which is odd, meaning what you haven't thought about, let's say a supercomputer, and you don't have an interface, but I have a supercomputer. Mm-hmm. Can I create it? Do you have to create it?
So it depends just how odd it is. I mean, we obviously have to have a way to connect to the platform. So our general architecture is agent-based, but we also have agentless, so as long as we can connect, let's say, via SSH, there's probably a high degree of probability that we would be able to connect to it and run work on it. We do have, as I mentioned, this kind of open platform to define any kind of applications that have automation APIs. We might be able to do that. So if we don't have to actually run on your platform, but you have some application that we could just connect to, via either conventional TCP or web services or something like that, we might be able to manage that without having to actually live on the platform. So there are a number of ways that we might be able to do that. Yes. Okay. Yes.
As far as I know, Oozie has most of the things you talked about. I'm a Oozie committer, and I'm also part of Yahoo Hadoop team. Mm-hmm. We have been using Oozie for a long time, and most of our job submission at Yahoo happens through Oozie. And okay. It's worked perfectly fine. And it has a lot of things you talked about. I'm not sure whether you know it or not. So it has a support of, post-operation, pre-operations, fork, join, a lot of things.
Sure.
So my first point is that, and it might have some limitation. So my point is that if it has a limitation and you think of it, why not improve Oozie rather than creating a new product?
Well, I could ask you that about Control M. We were around way before Oozie was. Why did you write Oozie? Why not expand Control M?
You open source it. Did you open source it?
No, we did not.
So you open source it.
So there is no question. There is no question. Right? Yeah. Oh, sorry. Go ahead.
So I'm saying that if you open source that, we don't need Oozie, right?
Perhaps,
so you should
but
open source that.
Well, right now that's not something that we are prepared to do, although who knows what might happen in the future. But as far as the point that you are making, so again, I think you and I spoke, and what we hear from customers and just people that we talk to, they see either they have difficulties, maybe there are features in Oozie that they don't know how to enable, but people definitely have some challenges with it. And it does work fine for some organizations. That's okay too. I mean, ideally, we'd like 100% of all customers, everybody who does computing, to use Control M. We know obviously that's not realistic. So there are going to be multiple choices, and if there are, if there's someone who finds that Oozie is acceptable for them, that's great. But the reason we have entered this market and what we have been hearing from the people we have talked to is that they see significant deficiencies that our solution addresses, but Oozie, at least they think, does not.
Yeah, mainly in terms of UI, I know there is no drop-off. Okay, mainly in terms of UI, there is no support of dropping and creating a workflow on fly. But if you use Cloudera Hue, which is again open source, you can do it.
I'd love to put Hue and Control M side by side and show you what are the differences between how you do drag and drop workflow creation in Hue as opposed to Control M. I'm familiar with it. I would argue that they're worlds apart. Sorry, go ahead.
So yeah. I've got a question. So we have quite complicated data processing pipelines, and we kind of like the idea of them being data-driven. So what we really like about Oozie and Falcon and Luigi from Spotify is they have this concept of a data-driven workflow, so you can basically kick off jobs not by having a tool like this where you make them dependent on each other, but when a partition becomes available in Hive or a certain partition becomes available in HDFS, it can kick off jobs based on data availability. Does Control M have anything like that?
Yes, it does. And, you know, so this is one of the things that if I have the opportunity, I will probably say it about 20 times in a conversation. From a high level perspective, the concepts that you're describing have been around since the dawn of computing. And so this is what we've been doing. You know, I hate to say this, but on the mainframe, there was something called Dataset Triggering, which is exactly this, and, you know, it's been around for 50 years. So Control M has that in all of the environments. And when we added our support for Hadoop, we provided HDFS capabilities to be able to trigger workflows based on HDFS events, file creations, you know, and so forth. So, but we also have that, of course, in all of the other platforms that we support. So again, what we have done is generalize that capability, but provided it in this environment as well. Yeah. Last one, I think, and then we have to go. Yes, sure.
Scenario, if I would be about to create what I want to do in one day, I want to create a workflow. I want to work with a workflow, say a workflow of 10, 20 nodes, and I want to create it and I want to modify it 10, 20, 30 times in one day. Is this realistic to do?
Sure. I mean, I'm not sure what kind of modification you are contemplating, but absolutely, sure.
Okay, can be, of course, overwhelming, but in principle, it's possible.
Absolutely.
So I mean,
you can even, I mean,
the configuration of Oozie, for example, in terms of technical means, is so complex that you probably wouldn't do it in this speed. You could do it maybe technically, but practically not in that speed. The convenience of an interface is of great value. If you are working, if you're using the workflow not as a static setting, which is establishing your. I'm from a science environment, so we would want to work with a workflow as a scientific tool. That means scientists would be able to need to modify it rapidly without having endless courses for learning how to do it.
There's even, I mean, some of our customers don't have static workflows. They build them constantly. Every time that they instantiate a flow, they actually create it, they generate it. So it could be as flexible as that, but certainly you can modify it as frequently as you need to. Yeah. So unfortunately, I think we have to go. So thank you very much. And if you do have any questions, I'll be happy to continue a conversation outside.